Okay, hi everybody. My name is Aliaksei. I'm a developer. I work in Gurtam since the very beginning. And despite being a chief Gurtam architect, CEO, sometimes accountant, sometimes salesperson, supporter, I was always and I am developer. And I'm developing things around 70% of my time, and 30% I'm managing the company. So today I will tell you about our backend, the dark side of it, and it's a backend in telematics. And initially I will tell you a few words about the telematics, just a few minutes, so that you understand this business. Because I believe that any software can only be successful when it's tied closely to its business goals. So what is telematics? You know Internet of Things, yes? Please raise your hands who knows Internet of Things. Okay, like 60% of you knows. For 30%, Internet of Things is it's things. Thing can be your washing machine, the kettle, the vehicle, mobile phone. All these things are connected to some centralized or distributed system. So telematics is a segment of Internet of Things where things are moving and changing the location. Telematics appeared around 30 years ago. At that moment of time, nobody knows that it was a telematics. So the term appeared a little bit later. And Internet of Things also appeared not that far ago. So the best what you can do to test or feel the telematics, go to a Cathedral Square in Vilnius or any other place, find a green scooter, open the case, and then you will see this kind of board. In micromobility segment, it's a part of telematics with scooters. They call this board IoT head. In telematics business, we call it the device. And the device is responsible for fetching the location of the scooter, sensing various sensors about it, controlling some outputs like beeping, locking, unlocking the scooter, and delivering all this information to internet, to the backend server, and also receiving commands from backend server. So telematics is applied in a variety of sharing services. Without the telematics, these services could not be exist because the device is the thing that controls all the vehicles, bikes, and scooters. Then there is a vehicle tracking segment. It's a fleet management systems. This is where the telematics started. It's everything about controlling the fleet, fetching the location data for ERP, for reports. So a lot of money is here in this segment. And then there is a remote asset management. It's here you can find refrigerator tracks, Barbara, red tracks. They has a temperature sensor inside, and the telematics is responsible to maintain the delivery conditions, so the temperature is not that high. Then there is a new part of telematics is text location. So the small text like AirTag, you can attach it everywhere, and the device in this can feel via Bluetooth or not feel sense this text and deliver their information to the backend server. And finally, there is a people tracking, but not the child tracking, family tracking that you may expect, but more about business. And business, it's about sales again, field workers that go to some shops, or security guys that are traveling with a tracker, and the system should ensure that they are alive and visit all the geofences. That is. So looking at the scheme, we have a tracking unit, the host, then we have a device. Device is capable of sensing the location, receiving information from various sensors, do some controlling outputs over the host. Then there is a connection, and finally we have here the backend. This is where Flash is located. So via the internet, a lot of different kind of connectivity, 2G, 3G, LTE, 4G, 5G, Wi-Fi, LoRaWAN as well. So they establish connections to backend server via the internet. Here we process, analyze this information, and deliver it to applications. This thing, backend plus applications, call it Telematics platform. And you are interacting with the Telematics platform, and you know nothing about this one. So for you, you are working with the Bolt application, and you do not know what kind of backend they are using. And you don't know what kind of the device they are using. This business appeared around 30 years ago, and when it started, like all kinds of businesses, there were companies that were responsible for both the hardware and the software. Around 20 years ago, Gurtam appeared on this market, and we created the first telematics platform that was device agnostic. So it was capable to work with different types of devices, from different manufacturers. We were a pioneer on this market. Nowadays, there is no company, as far as I know, that is able to produce hardware and the software at the same time. They are outsourcing it. So it was not competitive for these companies. They lose the competition. And around 9 years ago, we started a fourth generation of our platform. And from the fourth, we started from the backend. And it was so good that we decided that we should open it to the public. And we have no right to lock it to a VLAN, to a Gurtam. And we created a separate product, Telematics Backend, that allows other companies to create applications to quickly use the telematics. So now we have 1 million of devices here on backend, just celebrated last week. And we alone as a platform celebrated this year 4 million of vehicles. So we are growing quite quick compared to the platform. Now, what is so special in telematics compared to other software engineering systems? First of all, we have a large variety of manufacturers, of device manufacturers. There are thousands of them from all ages. And all these thousands of manufacturers are using thousands of different protocols for the data delivery. They are packing data in different parameters. There is no standard protocol. Even single company, let's say Teltonika, that is one of the leading device manufacturers company they are located in Lithuania as well. They are using standard protocol. It's a binary protocol on top of TCP and UDP. And in this protocol, they are encoding the data from the device in parameter ID, parameter length, and parameter value. It's a sequence of these blocks is a message. And within each generation of their devices, and they have a lot of generations, within each kind of model of their devices, the parameter ID inside the same protocol means different thing. So it's very complex thing, actually, and it's constantly changing. Then devices are moving. They are changing connections to cells. And it means that we have a lot of opening, closing connections. And if you expect the device will send the data like a normal in computers, in computer science, we get used that if we are sensing something, it's time series data. And delivering this data to a server, we will deliver it in each next record will grow. Yeah, so timestamp will grow. And it's not the same with telematics. Device likes to send the data from a black box, send the data backwards, sometimes pick a record from 1 hour ago, after some analyzing of the data and deliver it to server. It breaks a lot of databases, actually, in time series. And finally, it's interesting, when we are selecting the network equipment in our data center, we are looking towards a packet per second ratio because the data packets are low in the size, and we have a lot of data packets, but not that much bandwidth. So basically 100 of megabits of the traffic, in this case, can kill switches that are capable to pass the 10G traffic. So we are choosing the equipment based on the different metrics and different properties. And then from another side, from application side, when we appeared, nobody knows about the Telematics Backend, so it was like again, FlashP was a pioneer on this market, and users or applications using us totally different. Some are expecting from us just to normalize the data. Some want from us remote control over the device. So they send an API call to FlashP backend. Then FlashP do some magic, sends the data to the device. Device activates or deactivates something on the unit, on the scooter, and sends the response back. And we reply to the HTTP REST API response with a data packet from the unit. So it's a lot of magic inside, and we handle this. And also, there are some applications that need real-time data, like sharing system, and some applications just need data for reporting. They are not care about the latency. And the new trend, what we see is that finally they understand that telematics backend is something, and they do not need to store the data on their side because it's a lot of data, and they outsource the data storage to us, and using our system to receive events when the trip has started, the scooter fall, whatever happens. So it's like event-driven system. And yeah, finally, I forget to say, the market is huge, and everybody want to have a cost-effective solution. It means that the price margin is low, and to give you an idea, the telematics backend sells each unit to a telematics service provider for around 1 to 3 euro per month. And let's say for backend, they maximum can pay 1/10 of it. It's like 10, 15, 20 cents per each device. So, and with huge problems from this side and from this side. This is why we need to create a very cost-effective solution. So finally, the FlashP software design, what we have. We have our system, we provide customers with 3 endpoints. One endpoint is channels. Channel is this entity that users are created to connect devices that are working on particular protocol. When they're creating the channel, they are provided with IP address and port, and to this address they can connect the device. Then they have a shared endpoint for REST API calls and shared endpoint for MQTT API. MQTT broker API they need to use when they want real-time data, so just event-based approach. And here with REST API they do whatever they want to kill our backend. Then we have strict 4 layers in the backend. On the top we have product gateway. Product gateway acts as HTTP server for REST API calls, as an MQTT broker for MQTT API. Its primary mission is to clear the traffic, understand if this user is able to use our system, limit it, validate the data they are sending to us, count all the data they are sending and inbox and outwards. Then they, after cleaning the traffic, they are creating internally REST API calls to internal system and MQTT another separate broker connection to internal systems, and then connecting this HTTP server plus HTTP client here, MQTT server here, MQTT client here, and proxy the packets. On the second layer, we have a telematics gateway. Telematics gateway is able to receive the data from devices directly here, they fall, and it can receive HTTP REST calls cleared by product gateway. For its processing these calls like get devices messages, create device, delete device, create user, users are processed here. So everything related to the telematics. On the next level, we have MQTT broker. This is the third layer in our architecture, and MQTT broker is responsible for all kinds of events that are coming in our system. And to this broker, we have connected all the components on top of the broker, and also users are able to listen for any event that is created by their entities. And we are publishing to MQTT broker everything. So any new message, any new property change, any event, even HTTP REST API calls, when they are processed by product gateway generate an event to the broker, and user can receive this event that somebody is using his account for API calls. And on the bottom layer, we have a database here. And database is designed to store all the telematics data and all the data we have in MQTT broker. That is, what's here is important is, first of all, 4 strict layers. So, database knows nothing about broker, telematics gateway, and product gateway. MQTT broker knows only database, but have no idea who is using it. Telematics gateway knows everything here, but do not deal with users, tokens, with accounts. It just receives this information, only cleared REST API calls. It's important. Then between all the layers here, we are using standardized REST API. So just single type of API, it's HTTP REST. In single, the request is in single format, JSON, and the output is also standardized. Then we have all the events are traveling here. We don't have any other event bus, only MQTT broker. And all these events are possible to be consumed by the user, not only by us, so the same set of events. Then all our applications are created on C, and on top of C there is a Lua scripting layer, so we don't use any other language for our applications, just they all created in C, and they're very fast. This is from cost-effective things. They're really fast, and they're very standardized. So we have the same login system, the same statistics counting system, the same, all the components of our application are very similar. And it's cool thing to use. Finally, to connect all these devices, to parse the data and communicate with them, we developed our own programming language. We call it PVM, Parsing Virtual Machine. Then all the entities that we have, devices, users, whatever, we store, initially we stored them in PostgreSQL database. Later, when we introduced it for ourselves, MQTT broker in 2018, we started to reflect all the properties that we have in Postgres towards MQTT. We call it state. Now we are slightly migrating. We don't use Postgres anymore. It's slow. It's not effective. And we are storing more and more data in MQTT. And all the fresh entities that we created this year, we are storing them only in MQTT. I hope that you know what is MQTT. Please raise your hand. Like 50%, okay. MQTT is a kind of event bus where you creating connection to MQTT broker, and then within this connection you can send messages and receive messages from the broker. Let's say Telematics Gateway establish connections to MQTT broker and then publish messages. Each message has a topic and payload. Topic is kind of like a normal string split by slash. And it's possible to subscribe. There are subscribers. They say, I want to receive messages published to this particular topic. So they are creating the subscription, and MQTT broker will deliver published messages to them. And there are some wildcards in topics, so it's possible to subscribe. Let's say we have topic MQTT broker as a. And it's possible to subscribe all topics that starts from MQTT broker and so on. So it's, I don't want to go into details. What is the storage in MQTT? When somebody establishes a subscription, subscribes to the topic, broker can have some retained messages previously published to this topic with a flag, retain. It means that store for this topic, this message. And when you subscribe to such topic, you can receive all the retained messages in this topic and its children. This is how we are using storage in MQTT. So we have special topics that are very standard way, and then properties, where the actual data is stored. And when we need to load in Telematics Gateway particular unit property settings, we just create a subscription to this topic, and broker will deliver its state data to the gateway. It means that we have hundreds of services here, but the data will be loaded only when needed. I hope I explained it a little bit. And yes, we have standardized horizontal scalability in our system. It means that, let's say, the logical block here consists of a lot of processes. And whenever we need to add more resources, like in Kubernetes, we just create additional service and install it to server, and all the systems will automatically use it. Okay, why a new database? It's an interesting question, why we created a new database, because when we started FLASP in 2015, there were a lot of databases on the market. The answer is very simple. We knew what to expect. At that moment, we operated around 500,000 of devices in VLAN hosting, and we knew how the data flow works and what to expect from the telematics. Also, we tested everything that was on the market at the moment, just to understand that there is nothing that can help us to survive. All the databases were cool in description, but when they started to send them data flow like 500,000 of devices, they will die. Not in a day, not in in a week, in a month. When the data volume became too much, they are usually dying. Then we understood that there are different types of entities we need to store in the telematics, and we want to have the single consolidated system for this, instead of maintaining different types of the storage systems and administer these systems for different entities. It's also an interesting point. So during our experience with VLAN hosting, we used Oracle Berkeley DB, and it was such a thing that initially we started to use Oracle Berkeley DB. Then we created our own synchronization system on top of it. Then we created more systems, and finally, in the end, we started to use Oracle Berkeley DB just to store, just like a persistent storage system, like a file system. And all the layers, we didn't use their layers. We created our own layers. Why? Because when we tried to use their layers, we have to debug a lot of things. And when we are pushing the software to the limits, we need to understand what's going on. And if you have ever tried to debug complex system written by somebody else, then you could understand it's impossible, and it's much better to just rewrite everything from the scratch, and when you know where to debug. This is what we knew, and we decided that we need to create own database because it will be easier for us to debug it. And finally, it was fun. It is fun. actually. And fun is the best motivating system for the engineer. Okay, let's go further. How MDB looks like. It consists of REST API and something inside. REST API for all the calls. So the system, so via REST API, it's possible to register some container, send messages to the container, read messages, send file, read file, and so on and so on. We have two types of services there, REST API processing services and nodes that are used for data storage. For servers, we are using one unit, standard one unit server installed in the rack. It consists of 8 bays with SSD drives. 2 drives we are using for in RAID 1 file system, and 6 drives inside this server we are using like a nodes where each service is mapped to a particular drive and can read and write from this drive in exclusive mode. And all REST API services are connected to all these nodes with data. And yeah, services like a telematics gateway, they have standardized HTTP REST API client that is able to connect and load balance all the calls between different services in our system. The key concepts are, so each entity, so we are using sharding, and each entity, like container with data, is located on different, on particular shard. This service maintains information about the binding of shards and the entities, and capable to route the call toward a particular data node. These services contain a copy, the full copy of the data for a particular shard. It's located here, and we usually operate 3 data mirrors per each shard. So it's full separate copies. They are located in different servers, in different racks, and even in different data centers. So in case we will lose the data center, we have to, we will still continue to operate fully. And then we are writing all operations. When we need to write a message here, registering, we are writing to all shards in parallel and acknowledge the call when at least 2 nodes committed that they received the data. And when we need to read the data, we read it just from one node. So very simple, you see. And in case of there is a hardware failure or software failure, mostly it's hardware, when the drive will die, server will die, the rack will be turned off. Data mirroring will activate automatically, so we have a range of nodes that are registered as a spare, and they will be automatically, the data will start mirroring automatically from one node to another, just so that we have enough copies of the data. And we also have a migration of entities between shards, so it's also an interesting thing because have you ever imagined on a distributed system like we have, it's not just 2, it's 25 of these, it's 500 of these services. You need to migrate the item between shards. It's an interesting thing, like you are locking everything, stopping the data flow to a particular item. We have this feature. To give you an idea what we are storing, just what kind of objects we are storing in the database. So we store in device messages, and this is time series data, and there should be no duplicates in data point. So each timestamp, it means particular message with particular parameters. Then we store logs, and this same data, but with duplicates in the same timestamp. It's possible to store more few messages. Then we have queued messages. They are generated when we need to create a buffer of the data, and we fill this buffer from one place and consume it from another. Also, MQT broker stores retains messages here, and we have a lot of them, and they are identified by the topic. Then we have events here, and they are starts from one timestamp to another timestamp, and they should not overlap. So it's a different type of the storage. Then we store in traffic from all the channels. So all the data generated by devices we are storing. We also store in streams, we also store webhook traffic, we store a lot of traffic, and it has different keys than all these systems. Then we have files. You know, as every developer want to, if they have own database, they want to have a possibility to create an own content data network. So we created content data network for us and for all the world. And finally, we have a metadata, and our system is able to stream the data. Like last year, we supported the media, live video streaming from devices in video telematics, and we also back it up them by our database. So, can you imagine open source or maybe proprietary database that is able to handle all these different types of entities? It's not possible. Just to give you the scale, we operate 167 unique data shards, 94 servers of this type, with 564 data mirrors, 25 type of services for these services, and two data centers in RAID 1 mode. There is. And next one thing that I want to highlight today on the question of why we developed a new programming language. It's, I don't even try to explain how it works. This is how it looks. But why? The reasons. Because there are so many languages on the market. So the very first is that the protocols of devices usually consist from some data definition, packet structure, and it's easy to use protobuf here, but they also have some logic. Like this packet will consist of this data, you need to include more fields if you have this bit set, and so on and so on. So, and data flow itself, because the language is not about the data, but it explains the data and the data flow, and data flow requires some logic. So we want to have some language easy to use that can explain all these problems in one line of code. Our system, this PVM hides transport complexity, so we just write TCP, UDP, MQTT, HTTP, and all the implementation behind it will just handle the HTTP packet parsing, MQTT traffic parsing, and so on. Then in our system, we need like developers from the big experience of protocols. We know that there is no device on the market that works exactly like written in the protocol. We knew it, so we want to have a strict checking of everything of the data flow comparing to the protocol. So our language is super strict. It means that if device sending its data in different format or too much or too low data, we will generate an error and we'll deliver user information on which place the parsing has been stopped and why. And from another side, as we know, we have so many protocols. We also have to protect developer from errors. So we also, during compilation, check that the parameter is defined. If you define the parameter mileage, for example, and you expect a double there, you cannot store strings there, and you cannot store negative values there, and so on. So everything is checked automatically as well. So and all the errors are transparently delivered to our users and to us. We received what we wanted. So the performance, the output of our team in terms of protocols and integrations is very quick, is very fast. And we also building all the protocols with tests. A lot of tests are developed. Everything that we made from real life, we put immediately in the test system. So we know that we are not only quickly develop protocols, but we know that if we will fix something, it will not break what we have. But the thing is that we have the output of our work increased much higher. And PVM is a compiled language, so we compile it, and its execution is very fast comparing to any kind of script language. And finally, we detected this year that it was easy to create a generator for the PVM code because when you ask LLM to write the code using math language, Python, for example, Go, it will create own constructions. But if you will train it to use only your language, it will start to sync with the logical blocks and use your language much better. So we actually were able to train LLM to generate our code for some kind of copilot that we use it internally very quickly, just a matter of a week or so. We are optimizing it all because it makes mistakes, but in general, it works very good. And it's like some bonus on top of own language. With a normal language, we could not reach it so good. And finally, have you ever imagined to create your own programming language? Yeah, it was fun. No, initially for a few years it was not that fun. We have second generation, and migration from the first generation of language to another generation, it took us 1 or 2 years because we had 100 of protocols and we like rewrote. There were no LLM at that moment, so we were forced to rewrote them one by one. It was a very routine task, but at the same time it was slowly. We migrated. Now we are running second generation of the language. Everything is perfect. And just the last slide from me. My advice. So first of all, for all developers, for all system architects, I don't know, for all people, make everything as standard as possible. So I told you about REST API, about just 2 languages, C and Lua, the standard framework, all the things. The more standards in your system that you will have, the better and simpler and quicker it will work. The more result will be on when you improve some small component, it will automatically span to the whole system. It's very important to maintain the standardization. Sorry. And I have 2 screens here. The second one is develop in-house. I understand startups that want to make things fast, so pick some open source libraries and just connect them, create some business logic. But if you want to differentiate, you have to develop. And don't afraid development. Cool things like programming language, database. Everything what I showed you on the picture, we develop it on our own. We have own MQTT broker, we have own HTTP REST client, server, everything on our created by us. I just had no time to talk. It will be too much, but this is approach that we are using, and it's really interesting and cool. And finally, make everything simple. And this advice, because if you see a scheme, if you are creating something and see a complex scheme, put it away and create a new simple scheme. At least this is from what you should start. At least when you're creating the first generation of the software, of the platform, whatever, mostly you will succeed only on the third generation. Keep this in mind. And it's when you have a simple system, you will always have a chance to complicate it later. When you will create it complex initially, most probably you will end in a dead end in a couple of years. That is, thank you very much.
Hi, thank you very much for this. Very, very inspiring talk.
Thank you.
Thank you very much. Okay, so we're going to go to question and answers. We already had a few questions on Discord. I wanted to see if there are any questions in the audience. Anybody has a question? Please. Hold on, they're bringing you one.
Hi, Aliaksei. My question is how to hire a new developer to your team if you are using your own programming language?
If you're using our own?
Yes, you are using your own programming language. It's not like so popular on the market, so how to find a new developer?
Oh, it's very easy. Actually, I believe that developer or engineer is not something related to the programming language at all. It's something like nothing. As an engineer, you have to think from engineering point of view. You should be able to build your experience in any language, and there is no basically difference between languages, frameworks. Everything is more or less the same. It's like in translation. If you have, if you know 5 languages, it means that 6 and 7 you will study very quick. The same for LLM. If it can speak 2-3 languages, then plus 20 languages, it will be trained very quick. The same with engineers. So there is no need to have some specialized level, some specialized knowledge. You just need to be smart enough, ready to study, and have a systematic approach in your minds. That is, it's not difficult.
Achoo.
You're welcome.
Okay, another question in the audience? Okay, so we'll take the, there's one over there. And don't forget, all the questions gets a gift, and for the best question, the speaker decides the best question, they get a special gift.
Thank you. So you said to keep it simple. So how should we manage, like how much time should we spend on refactoring our code and our project to organize it and to keep it like, to reduce the complexity, and how much time should we spend on developing new things, like how to manage that disparity?
I think a good approach from the very beginning to spend 30 to 50% on refactoring and improving what you have. But it depends on the state of the system, and if it's too bad, you need to just stop adding feature for a year, for 2, and simplify it. And after that, keep in a normal pace. If you will not do it, if you will not invest your time into the simplifying, into improving, removing bugs, we have 0 bugs. And a backend from 0 known bugs. In a backend with a 9age old. So this is when we have some bug, we are fixing it. And we don't go further before we'll fix. If this bug requires a fundamental change, okay, let's postpone all the features and make the fundamental change, but remain the architecture simple. That is.
Thank you.
There's another question over there.
Thank you. My question is, in the wild, there is a concept of IoT broker that looks quite similar to the presented scheme. They have like many adapters for receiving data. They have MQTT broker inside, and they have data bridges to export data. Some examples like MQX or HiveMQ. My question is, does the presented platform belong to the same class solutions, or it has some crucial differences?
In general, and yes and no, like all databases can store the data, but the devil is in details. We deal with telematics data. This is very special. And telematics data is not the same type of the data due to reasons that I explained initially, the complexity from both sides. There is no established market of applications, and there is thousands of manufacturers. And in the system that you told, as far as I know, I may be wrong, everything should be standardized via adapter, and it like kind of relies on a standard data packet in MQTT, like a JSON or whatever, should be standardized. So it's more or less the same kind of solution, but not from telematics. You know, telematics is special data.
So the difference is in the amount of protocols accepted and in the diversity of the data?
The data flow as well. Okay, in Internet of Things, even Internet of Things, the data packet is slow, low, yes? So it's the broker itself designed to pass a lot of messages, but there is a slow payload. For example, in our case, in telematics, what we found out and what we specialized in, is a very large data packets that are coming efficiently through the broker. So it's a different kind of the data flow, the volume of the data is the structure of the data.
I see, thank you.
Thank you.
Okay, do we have another question over there in the back?
Hello. I found it interesting that the database has a HTTP API because, like, typically databases have like a lower level protocol. So I'm curious why you chose HTTP as the interface for the database.
Because it's simple and standard. So it's for us it's absolutely enough. We are controlling both parts. The HTTP REST client and HTTP REST server, and we are using standard protocol because it's simple, and it's for the data volumes. It's now we easily can scale it. You know, like looking back to my advices, the third ones make it simple and make it standard. Yes, the first one. So here between layers, inside the layer, there are a proprietary binary protocol. For us, we call it MQ, between MDB API and MDB layers. But towards the vault, like the standard language between microservices, between layers, for us is HTTP, and it's absolutely enough for us.
Okay, do we have another question over there? There's one in the back and then one further up.
So with IoT data, you said low latency, right? So when dealing with business analytics side of it, I'm assuming you would deal with that. Timestamps. When is the data processed from the hardware to the backend, right? Which timestamp do you take? Do you send a timestamp, although it introduces some additional data, or do you process everything in the backend, and how do you deal with the sequencing?
Some protocols contain the sequence number, and usually, like the majority, 95% of the protocols contain the timestamp and attached parameters to this timestamp. So the timestamp generated by the device, and we store this device, plus we store and like server timestamp, the time when we received the message, and we provide this information to our users.
All right, thank you.
Thank you. And there was one a little bit further in front.
Hi, my name is Roni. This is a follow-up to the questions or the answer that you gave earlier. You mentioned that 50%, you try to focus 50% of your team's capacity on technical debt. I think all software companies have technical debt, and I think for any developer, it's a dream to be able to spend 50% of our time on actually improving the technical part of it rather than adding new business features. But I found 50% to be quite a very high number. How are you able to maintain, how are you able to stop features for a year or two? That sounds kind of crazy to me. Do you dedicate a team of developers to technical debt only, or how do you go about that?
Thank you, Ronnie. That's a wonderful question. I have a very short answer on this, and I have an explanation. The very short answer is find a manager in line, probably top manager, that will be an engineer. If you will work on engineer, the engineer will have the very top level. I will make decisions, and he will understand kind of the decision. Because Like if the CEO of the company is engineer, then you will have this 50%. If the CEO of the company is from the manager's world, and he's pressured with the KPIs, like number of revenue, whatever, and the competition, looking for competitors, okay, they have this feature, we also should have this feature. It will be very difficult for you. So you need to have another line of managers that will protect you. And these guys are very, but if you will have a top manager from engineer, it will be easier. This is the short answer, more or less. The hard answer, or more, a little bit bigger, is that, no, I see the time. Without this, without spending the time on refactoring, the thing is that you will dive and stuck in the swamp of the code, of the platform, of bugs, of all the things at some point of time. When you're creating some platform, you're creating it with some idea, some concept. Then you are adding features, yes, to this platform, I don't know, product. When the number of features outweigh the original idea of your platform, it's time to create a new generation. You need to rewrite it. Rewriting a platform like we have, like Vialon, for example, will take at least 2 years, at least, and we will start from rather limited system. So it's very difficult business decision. And in order to avoid it, you have to all the time constantly improve what you have and adopt it to these new features and change the architecture of the system. This is what you should do all the time. Either you will spend 50% of your time improving it and be happy because it will work perfectly and you will be happy like a developer, or you will be angry as a developer because whatever you're trying to add from one side will break something from other side. And you will, at some point of time, you will have to stop everything and spend a couple of years to rewrite a new generation. That is. But if you have a manager that is thinking from engineering perspective, then you can persuade it, because business that pays money, that earns money, is always dominates. And if you have engineers that understand engineers and business goals in one hand, then it can make better decisions. Thank you.
Thank you.